Aslam, my name is Talal Shaheen and my roll number is 234. So, the topic of discussion today is temperature. Temperature is the degree of sensible heat or cold expressed in terms of a specific scale. So, first of all, what is temperature? The temperature of an object is the measure of an average kinetic energy of its particles. If a cold object is placed in contact with a cold one, there is a transfer of thermal energy from one to the other. When both objects reach the same temperature, the transfer of energy stops because the average per particle is the same in both. So, for example, we can say we have a cold tub of water and a hot tub of water. If I mix the hot tub of water in cold tub of water, the heat from hot water will transfer to the cold water and the transfer of heat would stop when the temperature of both the cold and the hot water would be same. Now the next is heat and temperature. The heat energy from the stove burner warms up the water, and on the other side temperature the thermometer measures the temperature of the water. Now comparison between heat and temperature. So heat is a form of energy while temperature it is a thermal condition of body. Secondly, the heat flows from one object to the other object where the temperature is different or lower, because the property of heat is that it flows from higher temperature to the lower temperature. On the other side, temperature it is a quantity that indicates whether or not and in which direction heat flows. Number third, it is a total amount of internal energy, and on the other side it is proportional to average kinetic energy of the molecules of a body. The fourth point, it transmits the transmission of heat is total amount of heat remains unchanged. In transmission of heat, temperature does not remain same. The SI unit of heat is joule and the SI unit of temperature is Kelvin. Now, how are temperature and heat related? In our daily conversations, we often use the words temperature and heat. In physics, these two words have very specific meanings. Temperature refers to how hot or cold an object is. Heat refers to the amount of thermal energy that is being transferred from a hotter to a colder region. As we have discussed before, the property of heat is that it flows from higher temperature to the lower temperature. So it is written here in simple words. When we say heat the soup in an oven, we are implying that thermal energy is to be transferred from hot oven to the cold soup. In this way, the soup will be warmed and taste better. However, how can we ensure that the oven is hot enough to warm the soup in first place? You must have noticed that the ovens usually have temperature controls. This helps us to preset the oven of the desired degree of hotness. So how is the degree of hotness or coldness, that is temperature, measured? Now we will discuss how we will measure the temperatures and which scales are used to measure the temperature. The temperature scales. Several scales and units exist for measuring temperature. The most common being Celsius, Fahrenheit, and especially in science the Kelvin. First of all, Celsius scale. The Celsius scale is used for common temperature measures in most of the world. It is an empirical scale. Its 0 point is 0 degrees Celsius, being defined by the freezing point of water, and 100 degrees Celsius was the boiling point of water, both at sea level atmospheric pressure. Because of the 100-degree interval, it is called a centigrade scale. Now we can see the conversion formulas between the scales. From the first one we can see is from Celsius to Fahrenheit. The formula is given that if we have a temperature in Celsius, we will multiply it with 9 and divide it by 5 and plus with 32, and it would give us the Fahrenheit temperature. The second one is from Kelvin to Celsius. The third one is from Fahrenheit to Celsius, and the fourth one is from Celsius to Kelvin. So now the Fahrenheit scale. In the United States, commonly uses the Fahrenheit scale, on which water freezes at 32 degrees Fahrenheit and boils at 212 degree Fahrenheit at sea level atmospheric pressure. Kelvin scale. Many scientific measures use the Kelvin temperature scale. It is a thermodynamic or absolute temperature scale. Its 0 point is 0 Kelvin is defined to coincide with coldest physically possible temperatures, or you can say that at that temperature there would be no molecular level or atomic level movement, there will be no movement at all. The temperature of absolute zero occurs at 0 Kelvin, that is equal to minus 273.15 degrees Celsius, and the freezing point of water at sea level atmospheric pressure occurs at 273.15 Kelvin, that is equal to 0 degrees Celsius. Now, we've given different thermometers of different scales showing the boiling points and freezing point of water. What is freezing point and boiling point? Now we will see the freezing point and boiling point by definitions. Freezing point, or we can say the lower fixed point on a scale, is the temperature at which a liquid turns to ice, while on other side boiling point, or we can say the upper fixed point, is the temperature at which a liquid changes to gas. Now we will discuss about the temperature measuring devices: expansion devices, field system devices, electrical devices, and pyrometer. There are some other devices named as solid temperature measuring devices, liquid temperature measuring devices, gas temperature measurement. Now, the first one is expansion devices. There are two types of thermometers. Number one is capillary tube, and the number two is bimetallic thermometer. The first one is capillary tube thermometer. In capillary tube thermometer, it uses volumetric expansion of mercury with temperature as mean of indicating the temperature. It has a bulb formed by glass envelope which contains mercury. Range used in industrial mercury glass thermometer is minus 38 to 950 degree Fahrenheit. A thermometer is a device that measure temperature or temperature gradient, and temperature gradient is the degree of hotness or coldness of an object. Mercury in glass thermometer. The mercury in glass thermometer is widely used in both laboratory and industry. It is one of the simplest temperature measuring devices. It utilizes the volumetric expansion of mercury with temperature as a mean of indicating the temperature. As shown in figure, the typical industrial thermometer has a bulb formed by a glass envelope which contains mercury enclosed in a metallic wall. Now, the advantages and disadvantages of a thermometer: simplicity in use and low cost, portable device, checking physical damage is easy, power source not required, while the disadvantages are now cannot used for automatic recording. There is a time lag in measurement. Range is limited to about 600 degrees Celsius, and the last one is fragile construction.
Today the topic to explain is bimetallic thermometers. These are very efficient thermometers which are used to calculate or measure temperatures. First of all, there is the construction of bimetallic thermometer. It consists of two strips of metal welded together. Each strip is made up of a metal having different coefficient of thermal expansion. At high expansion metals, brass is used at low temperature and nickel at high temperature. Now, this is a function or principle on which bimetallic thermometer works. For a bimetal in the form of straight cantilever beam, temperature changes cause to free and to deflect, and this deflection can be related quantitatively to the temperature change. Deflection with the temperature is nearly linear, depending mainly on coefficient of linear thermal expansion. in war is usually employed as low expansion metals. It is an iron nickel alloy containing about 36% nickel. Its temperature coefficient of expansion is about 1 to 120 that of ordinary metal. As high expansion metals, brass is used at low temperature and nickel at high temperature as mentioned above. Now these are the advantages of a bimetal thermometers. They are simple, robust and inexpensive. This is the main reason why we use these type of thermometers. Their accuracy is between plus or negative 2% to 5% of the scale. They are fully mechanical devices, no need of power sources. These thermometers work best at high temperatures. Later on, these are the disadvantages of the bimetal thermometers. They are not recommended for temperature above 400 degrees Celsius, as this is the limitations of these the type of thermometer, which is about 400 degrees centigrade. When regularly used, the bimetallic strip may permanently deform, which in turn will introduce errors. So that's why we cannot use it for a longer time. Their sensitivity and accuracy is less at low temperatures, so that's why we can't use it at low temperature areas. This is a visual diagram of a bimetallic thermometers. We can see there is a socket, bearing shaft, guided and stamp and helical bimetal element which sense the temperature. By using this, we can point or scale this type of point and scale the temperature over the meter at the top. Now these are the field system devices. Pressure spring system. Pressure spring thermometer uses Bourdon tube for temperature measurement. It consists of a metal bulb having thermometric fluid, a liquid and glass or liquid vapor, and is inserted in a point at which temperature is measured. A metal capillary is connected to a bulb and transmits pressure to bulb. The length of a capillary tube also affects the size of the bulb. Pressure spring thermometer. The construction. This is the construction mainly shown in the diagram, which is below the well is shown in figure. The bulb is composed of a cylindrical piece of metal tubing closed at one end and with the capillary and extension neck inserted at the other end. The size of the bulb varies considerably depending on the type of filling medium, temperature, span of instrument, and the length of a capillary tubing with which it is used. So you can generally see this figure. In this figure, we can see that there is a capillary tube whose length and dia and height changes with the type of liquid we use in it. Pressure spring thermometer. This is the visual diagram of field system temperature measurement. By using this, we can measure the temperature in these type of thermometer. There is one is liquid field thermometer at the left, and at the right there is a vapor pressure thermometer. These are the limitations of these type of thermometer: limited linearity and prone to error. The bulb size may be too large to fit the available space. The maximum temperature is more limited than that in some electrical measuring systems. Proper calibration of bulb, capillary tubes and Bourdon tube is needed. If bulb is raised by a height h from the calibration elevation, then the Bourdon gauge experiences an increase in pressure equal to error is equal to density gh. This is the mathematical expression which is used to find the pressure which is increased due to the elevation or height h. This is the animated or picture of this type of thermometer or Bourdon tube which is used for temperature measurement. Now some are electrical devices which are also used for finding the temperatures. These are the types of these electrical devices. The first is thermocouples, then resistance thermocouple devices, and then thermistor. All of these are used for finding the temperature in different streams like in industries, etc. The first is thermocouple, which is explained by me. A thermocouple is devised for measuring temperature. It comprises two dissimilar metallic wires joined together to form a junction. In this type of junction, a small voltage is generated in the electrical circuit of the thermocouple, which can be measured, and this corresponding to the temperature. Due to that, as heat energy or electrical energy is converted into heat energy, which is then recorded by the thermometer and shown us on the monitor. This is the applicative diagram of thermocouple. When we heat a junction, we use or we can see the temperature over a meter. Then thermoelectricity. A thermocouple is composed of two dissimilar wires joined together so as to produce thermal EMF. A simple thermoelectric circuit composed of two wires of different metals A and B. Assume that left hand junction of the wire is the point of measurement. Then the left hand junction is called measuring junction, right hand junction is called reference junction, and it's frequently maintained at either 32 degree Fahrenheit or 68 degree Fahrenheit. Thermocouple measuring devices. The thermocouple pyrometer has the widest useful range and application of any temperature measuring devices. It provides an accurate and reliable indication of the temperature for many kinds of industrial application. They can be interchanged since they are supplied to a standard calibration. Now these are the advantages and disadvantages of thermocouple. The advantages are simple, rugged, high temperature operation, low cost, no resistance, lead wire problems, point temperature sensing, fastest response to temperature changes. And the disadvantages are least stable, least repeatable, low sensitivity to small temperature changes. Extension wire must be the same thermocouple type. Wire may pick up radiated electrical noise if not shielded. Lowest accuracy. Resistance thermocouple devices. Resistance thermocouple thermometers work by changing resistance with a change in temperature in a repeatable manner. Resistance thermometers are usually used to measure temperature between minus 200 degrees centigrade and 500 degrees centigrade. It means it has a wide range which is used to detect the temperature by using resistance thermometer. Now the remaining portion of this presentation is presented by our fellow members. Thank you.
Assalamu alaikum everyone. My name is Muqaddas Fatma and my registration number is 202. Let's have a look on the advantages as well as disadvantages of RTD. First of all, we discuss the advantages. Most stable over the time. It is most accurate device. Most repeatable temperature measurement. It is very resistant to contaminant or corrosion of RTD element. Let's discuss the disadvantages too. It has high cost, slowest response time, low sensitive to small temperature changes, sensitive to the vibration which means strain the platinum element wire, decalibration if the use beyond the sensor temperature reading. It has one of the major disadvantages, that is it is fragile. This is the diagram of RTD as we can all see there. Next one is thermistor. Thermistors are the semiconductor used as a temperature sensors. They are the mixture of metal oxide which is pressed in the form of beads, wafer or other shape. The beads can be very small or less than 1 millimeter in some cases. Thermistors are generally called negative temperature coefficient thermistor, in which the resistance decreases as the temperature increases. Here is the diagram. We can see that there is a switch, there is a thermistor, here is an ammeter, voltmeter. Beads can be very small or less than 1 millimeter in some cases. Thermistors are generally called negative temperature coefficient thermistor, in which the resistance decreases as the temperature increases. Here is the diagram. We can see that there is a switch, there is a thermistor, here is an ammeter, voltmeter, battery and variable resistor. Next one is advantages and disadvantages of thermistor. First of all, advantages: high sensitivity to small temperature changes. Second is temperature measurement become more stable with use. Third is copper or nickel extension wire can be used. Now let's move toward the disadvantages. Limited temperature range. Second is fragile. Small initial accuracy which means drift. Decalibration if used beyond the sensor temperature reading. What is the difference between RTD, thermocouple and thermistor? Let's have a look on the temperature range. RTD have a temperature range of -260 to 850. Thermocouple -270 to 1800 degrees C. Thermistor -80 to 150 degrees C. Then let's move toward the stability. So RTD is the best, thermocouple is low unstable, and thermistor is moderate. Then let's move toward the sensor cost. RTD moderate, low unstable, and thermistor is moderate. Then let's move toward the sensor cost. RTD moderate, thermocouple low, and thermistor low. Let's move toward the sensitivity, which is more sensitive. So the best sensitive apparatus is thermistor and the low sensitive apparatus is thermocouple. According to the linearity, the best one is RTD and the lower one is thermistor. If we want to specify, thermocouple highest temperature, RTD is for high accuracy, and thermistor is for high sensitivity. The next device that we use to measure temperature are pyrometers. So what is pyrometer? Pyrometers are used to determine the temperature of an object based on infrared radiation emitted by that object. This is the diagram of a pyrometer, which is a digital pyrometer. What are the types of pyrometer? There are basic two types of pyrometer: radiation pyrometer or optical pyrometer. Let's discuss radiation pyrometer first. So radiation pyrometers, they measure the temperature based on the radiation which is directly emitted by that body. So a hot body emitted infrared radiations. So radiation pyrometer measure that amount of the radiation emitted by that object which is hot. In this way we can radiation pyrometer measure that amount of the radiation emitted by that object which is hot. In this way we can measure the temperature of that object. Their ranges is 0.1. The next type of pyrometer that we have is optical pyrometer. Let's have a look on optical pyrometer. First of all, the optical pyrometer is a non-contact type of temperature measuring device. The optical pyrometer is used for measuring the temperature of furnaces, molten salt, overheated material or liquids. Optical pyrometer have a minimum visible radiation of temperature 600 degrees C and maximum temperature of the filament is 2800 to 3000 degrees. Advantages of optical pyrometer: it is lightweight and portable, good accuracy compared to radiation pyrometer. It may be battery operated or self-contained unit. No direct contact is necessary. The measurement is independent of distance between the object and instrument. Wide range of temperature. Let's cover other devices that are used for measuring the temperature. First of all, we have this category, that is mechanical methods. Expansion of solids, expansion of liquid, expansion of gases. Expansion of solid, we have two main things, which is basically solid rod thermometer, bimetallic thermometer. In expansion of liquid, we have liquid in gas thermometer, liquid in metal. In expansion of gases, we have gas thermometers only. Next one is solid rod thermometer. The solid rod thermometer have been operated on this formula, which is delta L is equal to L into alpha into delta T. Here L is the original length, alpha is the thermal coefficient, and delta T is the temperature difference. Delta L is change in length. The expansion of single metal is widely used in rod type of thermostat as switch, but it is not used for indicating thermometers. This is the diagram of solid rod thermometer. Assalamu alaikum everyone. My name is Muqaddas Fatma and my registration number is 202. Let's have a look on advantages as well as disadvantages of RTD. First of all, we discuss the advantages. Most stable over the time. It is most accurate device. Most repeatable temperature measurement. It is very resistant to contaminant or corrosion of RTD element. Let's discuss the disadvantages too. It has high cost, slowest response time, slow sensitive to small temperature changes, sensitive to the vibration which means strain the platinum element wire, decalibration if the